Welcome to the workshop, How to Manage the Edge and Internal Ingress at Scale with Traefik and GitOps. My name is Dylan. I'm a member of the Traefik team, and it's my pleasure to introduce today's speaker, Frederick Klingenberg. Frederick is a Traefik ambassador and a senior consultant at Orem AS, an information technology and services company out of Oslo, Norway. He has helped multiple large organizations, including Elkjøp and Hafslund Nett, adopt cloud-native technologies for critical services at scale. Today, Frederick is going to talk about how to deploy Traefik as an internal and external Ingress controller, how to manage it through GitOps, and how to have full control over the creation of Kubernetes Ingress resources. But just before I hand it over to Frederick, just a couple of housekeeping items. We welcome your questions throughout the presentation. Please submit them in the chat. Not the Q&A section, just the chat, and we'll do our best to get to them throughout the presentation. But for the sake of time, we may save some of them until the end, as well as, don't worry if we move a little fast. This workshop is being recorded, and you'll receive a recording once we have a chance to process it afterwards. So without further ado, here's Frederick. Take it away.
Thanks, Will. And welcome to this presentation called Managing the Edge and Internal Ingress at Scale with Traefik and GitOps. Like the Dylan mentioned, my name is Frederick Klingenberg, and let's try to keep this presentation a bit interactive, so we can post questions in the Q&A section. If there are kind of short, easy ones, we can take it as we go along. If there are a long one, I maybe even need a little bit more time to think about them, and we can kind of elaborate on them a little bit at the end. Super short, you can reach me at the usual places. So I have a Twitter handle, my old username at uni, FredRKL. I'm also at the Traefik Stack channel with my full name. Like Dylan mentioned, I'm a Traefik ambassador. So that basically means that I try to help customers whenever they have kind of somewhat similar problems to what I've been already facing with the customers that I'm working with. And feel free to connect with me on LinkedIn as well. That would be cool. So I've been using GitOps and Traefik on a project for Elkjøp Nordic. And Elkjøp Nordic can best be described as kind of the Best Buy of the Nordics. And they are located across all of North of Europe, and did sales on last Black Friday, or that's actually Black Week, for around $4 billion. So that's pretty big in the Nordics. They have 400 physical retail stores. Obviously, there's quite a big presence online as well. A lot of happy customers, like 9.2 out of 10 on happy customer rating. It's actually also 4 times bigger than the second largest player in the Nordics. And it sells like the Best Buy, so like electronic goods. So we have a customer story on the kind of migration where we're taking some of the lessons learned from on the Traefik.io blog. And hopefully Dylan will share that in the Q&A or the chat. And here you can read up a little bit more on the migration that we did. But the kind of high-level overview is that we that Elkjøp Nordic had a platform with hosted their microservices, and each microservice was an Azure app service. And that platform was popular, performed well, but as the number of microservices grew, the hosting and management cost started to get out of control. So the kind of enterprise cloud solution architect at the time, Henry Hagnås, he got the go-ahead from the board, and he started a rather large migration project where I was lucky to be a part of. And together, Henry and I, we built the Kubernetes platform that now kind of hosts the entire microservice platform. So kind of all the sales that goes through online goes through that platform and the Traefik, as well as the kind of sales devices that is the sales clerks in stores are using as well. That's also using this microservice platform hosted on Kubernetes. So what is this talk going to be about? And I think we'll start with the problem and take it from there, see where it takes us. And what begins as a kind of trivial infrastructure setup using Kubernetes can quickly get out of hand once you start to scale. This is something I experienced at Elkjøp Nordic. And by scale here, I mean the number of people working on the platform, in the platform team, and also number of clusters. So we had kind of dev, test, and production clusters, but we had also those for the microservice platform, as well as for the sales clerks devices that they use. So you're starting to lose a little bit track because there's so many changes going from different platform team members, but also from the different Kubernetes clusters. We'll come back a little bit to the problem in a couple of minutes. And I think also we should have some goals for this presentation, like what should you as an audience be left with here? Hopefully, if it all goes well, you'll be a little bit more familiar with the term GitOps, kind of what it is and why we introduced it at Elkjøp Nordic, so that if you have the kind of somewhat similar scenario that we described with this microservice platform, and you're running into some of the issues about managing scale, you can kind of take some of the lessons learned here and use GitOps on your own project. And also I want to achieve that you should understand a little bit how you can use use GitOps to manage those traffic instances at scale, like both internally and externally. But I think before we look at how you do the management, we need to get some of the terms described first. So going back to the problem that we started with, you're setting up your Kubernetes cluster. We used AKS, so that's a managed Kubernetes service in Azure, but it really doesn't matter. You can use it on Google Cloud or Amazon as well. You spin it up, you get an API server, you get the credentials, and as an admin, starting off, I was the only one, so you start issuing kubectl commands, right? You start setting up your favorite Ingress controller, and just go ahead. But there's a couple of problems with this this approach, and maybe somebody can post in the chat what the kind of problems that we'll be facing with this approach. Just give you like 15-20 seconds. Yeah, exactly. We're getting into chat now. Hard to keep track of changes. That's definitely one. And also what happens when the platform team, lacking visibility and traceability, that's definitely one as well. And once you have more than one developer in the platform team, because we started to grow, you're running into a lot of issues, right? You have this race conditions, who did what the kind of changes when. Also, what happens in a disaster recovery scenario? Typically, in the cloud provider, when you're using that, you're getting a new fresh API server, new certificate authority that signs the certificates. So you need to get the kubectl credentials again, and then you need to run the same commands. But I think it basically boils down to what you just mentioned in the chat. You're kind of missing a ledger with all the changes done to all of the ingresses and Ingress controller. And I think we all know a pretty good ledger, and that's Git. And we like this distributed version control. And I started thinking, why do we actually like it so much? I remember working on Subversion or version control before distributed. It's kind of a little bit of a pain. So it's kind of good to start working with those distributed version controls. But I think there's a couple of reasons why we like it so much. One is that it's per nature event sourced. Like you have these immutable commits. You can go back and forth in time. You're not able to change the commits, so you can get full traceability. You're getting auditing for free. So if there's some internal auditing, maybe the security department wants to see what's been done, when and by whom, they can quite easily look at the commits. There's really, really good tooling as well. So you have pull requests, so you can make sure that you have some checks before you're pushing things out to production, for example. And every developer knows about Git. At least they have to know about Git or distributed version control. So that's something you need to learn anyway. And this is something we see kind of on a general sense. A lot of things are moving into as code. Like you have infrastructure as code, you have alarms as code, load testing as code, and now systems as code. With Kubernetes, you're now actually able to describe all of your applications, your scaling, and how they're talking to each other. But to solve the problem here, we want to use Git, obviously, and we want to use kind of GitOps. So this is where GitOps comes into play. And we were solving the problems that we saw on the previous slide by going from kind of pushing changes to the clusters with kubectl to instead of having a component inside of the cluster that is pulling the changes in. And it's pulling from that repository. So now instead of those administrators in the platform team, for example, pushing things to pushing things to the cluster, they will instead make commits to the Git. And if somebody in the meantime had made commit, they will get a message, hey, you need to pull the latest ones before you're pushing your changes. So can they get rid of those racing conditions? And there's a couple of different GitOps projects. We happen to like Flux. It does the job. I'm not sure if it's the de facto standard, but it's a lot of people are using it at least. Yeah, and really good questions on the Flux version 1 and 2. I'll come back to that shortly. So GitOps is kicked off by a company called Reworks. It's an open source project and does a lot of things. So that Flux component on a very high level will pull changes from that Git repo and do the applying for you. Now you can actually say that nobody should be able to make changes to the cluster directly. Every change has to go through that ledger. And Flux will also go in this reconciliation loop. The question was, are you still using Flux version 1, or do we have migrated to Flux version 2? So for Elkjøp, Flux version 2, the part of Flux version 2 component doing the container registry scanning wasn't ready, and we needed that one. So we opted in for Flux version 1. But on the current project I'm working on now is for If, which is a very large insurance company. There we're using Flux version 2 for everything, both the platform and for the individual teams. Yeah, also a good question now, why choose Flux over Argo CD? Are there a specific advantage of Flux? Well, Flux was kind of the first one we tried, to be honest. I know a lot of people are using Argo CD as well. So I'm not sure what it would give us that Flux doesn't give us. So I have to come back a little bit back to that one after I tried out Argo CD. But I love to give Argo CD a try as well. But Flux had all the components that we needed. So this is the very, very high level. There are some super good presentations from Reworks, the one that's kicking off that Flux version 2. So this is from the Flux toolkit that's being used for building Flux version 2. So I'll not dive into super details here. There are some good presentations that you can watch from them instead. But need to know some of the components here because they're going to be relevant for the demos and how we're setting things up, managing traffic at scale in a few slides. So you have a source controller, kind of the Flux version is built on the Flux toolkit, as I mentioned. So you have this ripped out and created all this microservices approach. You have the source controller that's responsible for pulling in from a Git repo. You have customized that we're going to be diving into a little bit. That's take that YAML and applies it with the customization overlays. And if using Helm, you can just use that one as well. We happen to only use customize. We haven't seen the need for Helm in our scenario, but I know that a lot of people are using Helm. And you also have this notification controller that can notify the source controller whenever there are new commits directly, but it's also something that we use to notify different channels in Teams, or you can do Discord or Slack as well. Whenever there are some errors from customize, let's say trying to apply some YAML that customer doesn't have access to apply, and we'll see how we can control that one a little bit later. Yeah, I also got a question here about Azure DevOps, and I'll come back to that a little bit later. We're using Azure DevOps as well for the continuous integration. So there are multiple ways of managing clusters using GitOps. And although WeWorks have some kind of recipes or some ideas, it's really up to you. You can do it however whatever fits your project. So this is how we did it at Elkjøp. And this is also how we're doing it at the project I'm working on now. And here you have, contrary to what you're often being told, long-lived branches. So you have one branch representing each of the environments, dev branch for dev, test for test, and so on. And this is pretty cool. So you make changes to the dev branch, that's been reflected in the dev environment. And then you can kind of compare branches, see exactly what kind of commits done by whom. That's not yet to be applied to test. And this is a game changer for us because now we have full control over what's in dev that hasn't been rolled out to test, and who did the changes in dev, for example, that isn't rolled out to test. And the tooling is really, really good for making those. So you're comparing branches. So we happen to use Azure DevOps. We have the Git repositories there, but you can use GitHub and other tools as well. But there may be some differences from the different environments. Like maybe you have some ingresses. The ingresses probably is going to be different from dev to test, for example. And there may be certificates and stuff like that. So does anybody have an idea how we can manage that? Just give it kind of 10 seconds. Yeah, one way of managing it is by using customize. And I'm starting to become I'll answer that question as well on the branching part. So we're going to touch upon it on the customize here. And I'm starting to become a really, really big fan of customize. I think it's a really, really good tool. It's actually a native tool that comes shipped with kubectl. So you probably already have it. And instead of kind of introducing a templating language like Helm, you work with what they call overlays. So you start with a very high level. We'll do a demo, super easy demo, but you start with the base stream of text. You can transform it, and that could be the input to another transformation. And you can kind of build this upon each other in a cascading manner as much as you like. So that Let's go in and look at a super simple demo. Hopefully you'll be able to see my Visual Studio Code, and shout out if that's not the case. Yeah, thanks. So again, there are different ways of doing it. This is one way that we're seeing going that a lot of people are using. But again, Customize doesn't dictate one way or another, but this happened to work good for us. So you have this base folder, and Customize that comes with will look for a file called customization YAML. Customization YAML on the left-hand side there, you have a lot of parameters that you can configure there. This is the kind of the easiest one, where you specify what kind of resources it should be streaming. So this takes the file traffic proxy, and who am I? Just a super simple application, creates a stream of YAML, and that's it. What you typically do, you have this base, and then you have these overlays. We now only have one overlay, and that's in production. So here you see that the power that comes from the cascading manner. So this one goes into the base folder, gets the stream, and then Customize has this patches strategic merge, where it's actually able to take that stream of text and apply this merge from the tracker proxy patch, and that's the file on the right-hand side there. So here it's actually looking, matching for the API version, kind, and the name and namespace, and changes just the replica. So if you look at the base folder for the traffic proxy, which is the one down inside there, you see the replicas being 2. But here you're saying that everything should be the same, except that you want to change the replica to 4. Again, that Customize is not kind of a glorified grep tool and doesn't do pattern matching or something. Like Customize actually knows about the Kubernetes object, so it's pretty clever about it. So we can probably run a demo now. I have an alias for kubectl, so I just call it K. And if you do Customize overlays production, we should now see output of the text a little bit more, and say that the deployments of the traffic proxy should now be 4, and the replicas is 4. So it worked. Don't see my console. Let's see if I can, sorry. Can you see my console now? Perfect. Thanks, Andreas. Yeah, so I just ran this Customize and done it for the production. And here you see that it changed the deployment going from replica 2 to replica 4. But it's even more powerful than this, because we can go in here and we can have another property, say namespace. Oops, namespace should be, this is a test. If we run it again, Customize, it's clever enough to change the namespace, obviously, on the deployments, the service. But as you can see here, once you come into cluster role, it doesn't add the namespace, because cluster role isn't namespaced. It's a kind of global. So it's, again, not a glorified grepping and pattern matching tool. It's really, really clever about those things. So hopefully you should see my slides again. Yeah, so you kind of want to have all of the YAML, rip it out from the application repo, put it in that repository. But you want to kind of recreate everything. So when you have the secrets there as well, this poses a problem, because you don't want to have your kind of secrets, even though it's base64 encoded, it's just encoding. It's not, secrets is still there in more or less in plain text. So, so there are some different tools of managing this. We use the sealed secret. I know there's a tool from Mozilla as well. We happen to like sealed secret. It worked really, really good. And this is the kind of missing piece that made it possible for us to keep the entire state of your entire system, all of your application in that repo. So the kind of gist of it is that you have a public and private key. You deploy a controller inside of a Kubernetes cluster that's called sealed secret controller that obviously has the private key. The public key is public. Everybody can see it. There's nothing secret there. But then you use a tooling called kubectl to encrypt your Kubernetes YAML secrets and instead create this sealed secrets. And once that controller sees those CRDs of type sealed secret coming into the cluster, it uses the private key to decrypt them and just create the regular secrets. From all of your applications running inside Kubernetes and how you're managing secret, it would be just as in the regular secrets. And we have a demo of that one as well. So here we have a secret. It's just base64 encoded. So you see my console app as well. This is a secret, right? Super secret. And there's a good tooling, so you don't have to kind of use a lot of complicated tools. There are integrations to a lot of the editors. I happen to use Visual Studio Code, and the public key is public. So if you're able to get the private key from the public one, well, good job. Then we probably have some issues and problems on the internet as a whole. So what you do, you can just use that kubectl plugin that you use in Visual Code and say, like, please seal this secret. It should be strict. You can use it like, should the secret be able to move from namespace to namespace, from cluster to cluster? We just want to have it on this cluster in this namespace. And then it sees that, yeah, it should be a test. The namespace should be a namespace. And then it asks for the public key, which we have here. And then you're getting this Bitnami CRD sealed secret. And this is encrypted. So you will not be able to get the super secret text for this one. And this is obviously the one that you're checking into Git, not the secret in base64 encoded. Yeah, so let's move back a little bit to the Traefik deployments. So we saw here that we can have, we don't want to have this one. We can make changes, and we have I already have a cluster where we have Flux working. So this is here. So Flux also comes with a CLI, so we can get kind of Flux. And you can kind of bootstrap everything. If you're on a totally new cluster, you can check, and you can get the sources and also the customize and the status, etc. So for example, here we have the GitOps, the Flux version 2 running. So if I do Flux get sources git all, you see we already have a component, going back to that slide on the GitOps, where it's fetching now from this repo that we just looked at on Visual Studio Code. And we can do Flux get customizations all, and we see that that customization, okay, the apply failed here. Let's see if this works then. So if you make changes to this one, we see that we have now changed the replica count. One or more replicas. We are pushing that change. And we're seeing that we get a new commit now. It's called D9C. And we also happen to have the repos here. 9DC. And Flux, get sources, git all. It has the previous ones currently because it runs in this loop, so it sometimes takes a little bit more, a couple of seconds before it pulls in the latest one. So this is where the notification controller comes into play. So you can configure it to listen to, for example, Git, and notify this controller that, hey, there's a new commit. Right now, it just runs in a loop. So I think every 20 or 30 seconds, it should get the, it should try to get it. So D9C, that was the latest one, right? And we can see that Flux get customizations on all namespaces. It's actually applied it as well. We are in that one, so we should, oops. You see now 51 seconds is actually now have a new pod. And again, I haven't pushed and done anything. We're getting a question like why choosing a pull null Flux versus push in terms of workflow. I have some slides on that one that shows a lot of good benefits from it in terms of disaster recovery. Maybe don't have access to those clusters to do the pushing and other things. Well, it's a really good question, and we'll come back to that. Thanks for that. Yeah, so actually, I think we're going to be addressing that question right away. Like you have with the GitOps approach, you have a very sharp separation between continuous integration and continuous deployment, right? The continuous integration stays exactly as it has already been done. You're doing some unit tests, you're doing some static code analysis, you're building stuff, and ultimately in the Kubernetes world, you're creating an image and pushing it to a container registry. But this is where we have a very sharp separation. It's not passing over any YAML to the continuous deployment part. It's totally separated. And one of the good reasons of having that separation is because sometimes you don't have access to pull to push to those Kubernetes clusters. Maybe like I'm working in an insurance company now called If, like I mentioned, they're super strict about it. Like they have no public IPs if they can get their way. So for example, the Kubernetes cluster is totally private. But the security-minded security departments often say that even though you can't kind of open up so arbiter people can push to that public IP, we could flip it around and say that you can have a component inside of a cluster, such as Flux, that's able to pull and make SSH connections to the repository. That's fine. So that's actually what we did. We said, yes, please can we get an opening in the firewall to do SSH to Azure DevOps, which is our repository place of choice. And that was fine. And you can also imagine that you have this on the edge, right? You have Kubernetes cluster on boats, for example, where you're on sea, maybe you don't have internet access, but you want those clusters to kind of pull the changes and apply it once they do have internet access, instead of having a pushing, having something trying to push every single time. So yeah, so you're moving from this continued pushing to having them instead pulling those changes from traffic. Let's move on a little bit to Ingress management. Like something we all love with Traefik and Kubernetes is the automatic discovery and configuration of traffic based on ingresses. So Traefik is able to listen to Ingress objects or the CRD if it's the later version of Traefik and configure itself. So you can just create an Ingress and it configures it. However, this is fine, but it could also pose a bit of a problem. Like what happens if all the different teams that you have start creating Ingresses and use domain subnames without any coordination, right? And if you combine that with kind of wildcard redirection to your load balancer, and you're kind of begging for trouble down the line. And again, we're not trying to restrict the teams so that they will move slowly. We're just saying that you should be able to do things fast, break things if you can, but we want to create some guardrails, right? So if you're creating a service of type load balancer by mistake, you should just get notified by that. And then the same goes with ingresses. It's something that in our scenario, we want to manage from the platform side. But again, it boils down to what you want to do as a team. But this is actually something that we can manage and have a little bit more control over using GitOps as well. So you mentioned that we have this Git repository in customization on some previous slides. Those are the Kubernetes custom resource definitions that you will be using, and we'll look at a demo of that one as well. But you're creating this Git repositories that's responsible for pulling and changes from a Git repo, and then you have this customization that takes that YAML and do the customize that we just saw on the previous demo and applies it. But what's really, really cool and gives us a lot of control are two things here. One is that you can have customizations depending on other ones. So for example, at the insurance company If, and we also did that at Elkjøp, we use a product called Linked, which is a service mesh. And Linked has a really cool feature where it's actually able to automatically inject a sidecar proxy into your deployments, for example. But that's a part of Linked that must be up and running before you're running up the other ones, obviously, because it's part of the initialization. So what we do is to say that this customization can be applied, but it can only be applied if all the health checks turns green on the Linked part. So the customization can then say that check these endpoints. If these deployments are good to go, all the pods are up and running, then start applying it. So on both Elkjøp and If, we actually depending on Linked. You could obviously go a bit crazy here and have a very elaborative dependency tree, etc. We try to keep it as a super minimum. Like Linked must be up and running. You can argue that the same goes for Prometheus. Like you don't want to bring the application up before Prometheus because you really want to have those metrics from the start. or maybe you don't. Maybe it's not that important for the matrix. The most important thing is that our application up running. Again, up to you as a team. But another very powerful feature here, which gives us as a platform team a lot of control, is that these customization, we'll take a look at it shortly, can actually run as a service account. And this was a game changer for us, because now we as a platform team can say, put all the YAML in the repo. It will only be applied after the linked has been applied. And you will only be able to apply that whatever the service account is able to apply. So for example, if you drop some YAML defining some ingresses inside your Git repo, we are basically said that this service account is not able to apply, it's not bound to some role or cluster role that gives you permission to apply that ingress. So now we suddenly have full control. Again, we don't want to hinder the teams. They can create ingresses if they want, but it just won't be applied. You will get a message from that notification that we looked at earlier and if we give them the notification in specific channels in Teams, saying that, I'm sorry, you can't create ingresses. So what we're moving towards now is that we have a platform team. This is how we're doing it at IF. That's creating cluster roles, kind of global objects in Kubernetes. But for each team, it creates a namespace. It creates a Git repository CRD with the customization that's pulling in for a specific Git repo. And that Git repo a team will have access to. And we do that for each and every team. So for the individual teams, they will typically have, what we're seeing now is that they have a repo where they have all the application code and all of the Kubernetes YAML files. So for each of those applications, you typically take and rip out all of the YAML and put that into that repo that we just showed on the previous slide that we give them. Put all the YAML that describes all your applications and basically describes your system. And speaking of systems, you typically have more than one application running in the system. So yeah, one of the repo represents one namespace, which represents a team and a repo. Yeah, let me quickly see if I can show. Yeah, some of the consequences of doing the GitOps approach and managing your ingresses by doing that is that a lot of the bootstrapping becomes really minimal and simple. So what we have to be able to spin up a cluster, we have very, very few components that we're going to be looking at, and we're actually able to spin up a cluster from nothing to get it up to where we left it with all the YAML, all the states, all the secrets in about 20-25 minutes. And the only reason why it takes 20-25 minutes is that we're waiting for the virtual machines making up the nodes to provision. And we're obviously waiting for the images to be downloaded. So if those things would have taken 0 seconds, we would be up and running really quickly. So this is something that's really good for disaster recovery as well, keeping all your entire state in Git. And what we're doing now is kind of saying that instead of making large changes to the cluster, so for example, instead of updating the Kubernetes version, even though it's really good support for doing that on the fly in AKS, for example, we're using Azure for this one. We're saying that for those changes, which are so all-encompassing, we rather take down the cluster, update a small part of our bootstrapping script to have a new Kubernetes version and bring it up again. And this way, we're constantly training on disaster recovery and having everything. So whenever is a large outage, we are ready for those. I have a demo. I'm not going to take down the cluster, but I'm going to show you the kind of script and how easy it is. So we have a kind of Traefik Bootstrap script for this cluster, and it basically does just a couple of things. Install that sealed secret controller that we talked about. So it has the public private key, creates components making up that one. It installs the Flux version 2 components, and then it starts with the synchronization, and it starts syncing in for the Traefik deployments. So let's quickly show a demo of how that is. Hopefully you will be able to see my issues with the code again. Shout out if you can see it. Cool, thanks. So this is the bootstrapping script. Again, we're using Azure DevOps to do the bootstrapping, and we have a pipeline there. So setting or bringing up a cluster it's literally a push of a button, and then everything is brought in again. And you see we're using the Azure CLI. We could here use other tooling like Terraform or something like that, but again, like all the states, it's in GitOps, so we really don't need it. We want to keep this as minimal as possible. So this just create the cluster, get the credentials for the new cluster because they're a new API server. We install the sealed secret controller, where we are kind of taking some environment variables for the public private key, so it's not here in this repo. We are installing the GitOps components, and then we are bootstrapping up production. And here we see, going back to that good customize tool, here we see that, yeah, apply this one and the base. So here it takes the Git repository. This is the CRD part of the GitOps toolkit, making up Flux version 2. And it should just, from main branch, you should then pull in everything. And here's the SSH credentials. And then you have the customize, saying that take everything that you got from that source and apply the overlays production. And here we see the pipeline. So we have pipeline as code as well. Right now it's just triggering on main, and this will be different when you because I just created a super simple example. Here we have the environment variables where you have those GitOps public private key, and that's basically all the kind of secrets that need to keep outside. This is a very simple solution, like we're just defining kind of hidden environment variables in Azure DevOps. You could use other tools for this one as well, but it happens to work for us. Yeah, that's pretty much. I think we're right on time for some questions. And to summarize, like, we're moving a lot of the state into GitOps, and by doing that, and moving from the push-based to the pull-based model, you have a host of benefits: disaster recovery, private clusters, and full control also on applying, so that you can give the kind of teams free access to do whatever, but you're kind of protected against yourselves. And this is also something that applies to the platform team. Like, we all make mistakes, but we want the tooling to say that, hey, are you sure you mean this? And no, of course, if you make a mistake, you don't mean it. Cool.
Excellent. So thanks, Frederick. So everybody, we have about 9 minutes for questions. So we had one question here that says, if teams can manage their own YAML, how do you confine their play area for things like SSL certificates, hosts, DNS names? For example, how do you protect people from stealing the URL of another team?
Yeah, so this is different ways of doing it. Obviously, right now, if we are saying that you can't create those ingresses yourself, that's something that our platform team need to coordinate. So we create the ingresses for the different teams. Say that, hey, this is an ingress. It's been configuring traffic or another ingress controller, and then you need to create a service that the ingress has been pointed out.
Gotcha. Question from Andreas, a new service API? I'm not sure what exactly is meant by that.
What do you mean, Andreas?
Would that not solve the problem with subdomains?
That could very well be. I'm not sure, to be honest. I would love to have a chat about that. Definitely.
Okay. We have another question here. I have a question about middleware limit. I use Ingresses defined in CRDs, migrating from Nginx. Some of my domains have 2,000 redirects. I define all of them in middlewares. Is there a better way to manage such large configurations?
That's a little bit out of this scope. I mean,
we can take that one offline.
Yeah, I think we'd have to take that one. I'm not quite sure what I mean by that. Yeah, okay, so you need a new service API like the gateway API. Yeah, I'm starting to look into that one as well. Like, I have a lot of other capabilities is there, and I know that the new gateway API has really been focusing on giving, like, you're the platform, you define these components, you're the teams, you define these components. But again, I think still there, you want to manage, like, these are the ingresses that you can create.
Okay. We have another question from Nicholas. How do you upgrade traffic for minor and major versions with this setup?
Yeah, for those one, we could actually do a live update now. We right now we're just updating the version in the YAML, do a commit, and then it's being rolling updated on that one. So I think also you meant, like, yes, we could say that we want to do a shutdown the cluster and do an upgrade on that one. It's a balancing act. Like, if you want to, if this is a large enough of a change so that it poses a risk that we will have downtime, we want to shift that to kind of taking down the cluster, do changes and bring it up again. So for example, for Kubernetes version, it's a quite large change in the control plane and the data plane. Whereas kind of just the minor version of traffic, it's for us, it's a small change.
Okay. Thanks for all the questions, everybody. This is
great. Really, really good.
We have another one here. So what's the best way to manage wildcard domains without defining each host separately?
Wildcard domains right now, we have a wildcard redirect to a cluster, and we have a wildcard certificate on the root. So it takes everything on that one. We have a default certificate on traffic, so it applies to everything.
Okay, here's another question for you. Do you install the traffic CRDs as a separate customization before the traffic deployments?
Yes.
That's an easy one. What do you mean by defining each host separately? That's in relation to another. Oh, that's another question there.
Yep.
Well, that looks like all the questions for you, Frederick. We have a few more minutes. Anyone else have any questions? Going once, going twice. Well, Frederick, thank you so much.
Thank you.
This was a great presentation.
Thanks.
Excellent to see. Thanks everybody for joining today. I'll go ahead and give you a few more minutes back in your day. One thing I do want to say, feel free to reach out to us on Twitter at Traefik, that is Traefik. Our community and ambassadors and our team are very responsive. So if you need anything, you can reach out there or reach out to us on our website, traefik.io. Also, a quick plug, we have a workshop tomorrow, about 30 minutes before this one started, that is on advanced load balancing techniques with Traefik 2.5. So if you're interested in that, but you can attend, great. If you can't make it, but you're still interested, just make sure to register. I'll post the link here in the chat, and we'll send you the recording. And again, this one is being recorded and you'll get this one pretty soon. So thank you, everybody.
Thanks.
Excellent. Have a great day.